Alright, boys and girls, today's lesson is lesson 3-5, and it's called Relate the Three Methods. So basically, we're going to continue talking about the three methods, and we're only going to work with 4-digit dividends. That means the number that's getting divided. And of course, I'm going to throw in my last method that I like using. So I'm just going to continue for probably about 7 or 8 minutes of lesson. I'm just going to do a couple problems. I'm going to do it all 4 different ways, and then I'm going to send you off your way to continue working. So to start, I'm gonna get. Well, first I better pick a real cool color because I know you guys like these fun colors. Let's see if I can find something. How about this one? That would look cool. Let's do 4,853 divided by. Let's go 5, because that'll make you think a little bit. All right. So the first way I want to do it is I'm going to move this out of the way. Actually, you know it's less than 3/5, so I'm going to put this right here because I'm going to do everything hopefully underneath it. So the first method I'm going to do is a square method. Okay, place value sections method, whatever you want to call it. I call it square method, just because it reminds us of our, when we do multiplication, a similar way. I didn't make enough room in here to work with, but there we go. I'll shrink it down when I'm done. So 4,853, it's going to go, 5 can go in this many thousands, plus this many hundreds, plus this many tens, plus this many ones. Then you would add it all together. This is a 0, not a 6. So by looking at it, you already know the 5 can't go into the 4. Okay, so your answer here would be 0 thousands, because 1,000 would give you, 1,000 times 5 would give you 5,000. And that's already more, so that doesn't work. It's okay to put a 0 in one of these boxes. So we're going to do 0 times 5, which equals 0. So 4,853 minus 0 is 4,853. So then you roll that over to the next box. 5, how many hundreds can go to 4,853? Well, I'm just going to look at the first 2 digits, and I see 48. Well, I know 5 times 9 will give me 45. So let's try 9 hundreds. That would give me 4,500. Bring it down, you get 3, 5, 3. So 353, put in the next box. Now I know that 5, how many times can 10 times 5, or how many 10s times 5 can go into 353? Well, I know 5 can go into 35 7 times, so let's try 7 tens. That would give me 350. Subtract, you get 3. So 3 is in the next box. 5 can go into 3 0 times, because 5 times 1 is 5, and that gives me more. 5 times 3 is 0. Subtract it, you get 3, so there would be a remainder of 3. So your answer would be 970 with a remainder of 3. Alright, so let me kind of get this out of the way. That was one method. Now I'm going to do the expanded notation method. Basically, we build up. 4,853. So I'm going to say 5 times, let's do 900. Will give me 4,500. Subtract, you get 353. Then you get 5 times, let's do 70. Will give me 350. We'll subtract it, you get 3. That's a 7. And now my number is lower than my divisor, so I have a remainder of 3. You add these two together, you get 970 with a remainder of 3. See how much quicker that was than the place value sections method? I think that's pretty sure what I got. 970 remainder of 3, 970 remainder of 3. So I'm going to shrink this and get out of the way. I'm going to do the digit by digit, or the way I used to do it when I was little. And it would go 5 can go into 4,853. I first look, and can 5 go into the 4? It can't. So I do a 0. 0 times 5 is 0. Subtract to get 4. Then my 8 falls down. 5 can go into 8 9 times, or 48 9 times, to give me 45. Leaves me a 3 left over. This 5 comes down. 5 can go into 35 7 times, to give me 35. Subtract it, you get 0. The 3 falls down, and that gives you 5 cannot go into 3 at all, so 5 times 0 will give you 0, and subtract it, you get 3. So 970 with a remainder of 3. And then I'll do it the way, my extra method I'm showing you that I really enjoy, the partial quotients method. And that's where you just draw the line on the side. Someone said yesterday the sevens method, or the seven method, because it looks like you're making a big 7. Which is a good idea. So 5 can go into 4,853. Let's say 900 times. If you multiply 900 times 5, you get 4,500. Subtract it, you get 353. I know 5 can go into 353 70 times to give me 350. Subtract it, you get 3. 5 cannot go into 3. This number is now smaller than the divisor, so that tells me that's my remainder. And I add this together. Oops, I have 970 with a remainder of 3. All right, so those are my 4 methods, and I know I continue to just cram these and cram these and cram these, but there's nothing wrong with that. That's how you become experts at it. Just think if you knew how to make a free throw and you made 2 free throws in a row, and you're like, I'm good, I can make free throws anymore, I don't ever need to practice them. And then you become a really terrible free throw shooter. So we don't want that. All right, so I'm going to switch up the colors here, and this one I'm going to do one more 4 different ways, and I'm going to send you on your way. All right, let's do 8,353 divided by 7. I'll do the square method first, or rectangle method, because I guess it really isn't a square. So 8,353 divided by 7. How many thousands can it go in? How many times 100 can it go in? Sorry, put too many zeros on that. Or how many hundreds times 7 can it go in? How many tens times 7 can it go in? How many ones times 7 can it go in? Well, I know by looking at it, if I go 1,000 times, I'll get 7,000. If you go 2,000, you're going to have way too much. So 3, 5, 3, 1. So 1, 3, 5, 3. Next. How many hundreds can it go in? Let's see. How many 100 times 7? If I go 200 times 7, I get 1,400. So that's too much. So we'll go 100 times 7 to give me 700. Subtract it. 3, 5, and then I have 6. 653. How many times can 7 go? How many 10s times 7 can go in 653? Well, I know 9 times 7 is 63, so you put the 0 on for 9 tens. Give you 23 as a remainder. And then 7 can go in 23 3 times to give me 21. And 2 is left over, so that's my remainder of 2. So 1, 1, 9, 3, remainder of 2. All right. Shrink that out of the way. Oh, I don't want to forget my 8,353 divided by 7. That is sloppy. I'm embarrassed I wrote that. I'm going to rewrite it. Okay. 8,353. 8,353 divided by 7. Let's do the way I grew up method. How's that? 7 can go into 8 one time. So 1 times 7 is 7. Subtract it, you get 1. 3 falls down. 7 can go into 13 one time. 1 times 7 is 7. If you go 2 times, you'll have 14. That's more. So don't do 14. I know it's close, but it's over. 7 times 1 is 7. Gives you 6 left over. This 5 falls down. I know 7 can go into 65 9 times to give me 63. Subtract it. You get 2. 3 falls down. 7 can go into 23 3 times to equal 21. Remainder of 2. So 1,193. Remainder of 2. All right. Let's do it the expanded notation method. That's where you work your way up. 7 can go into 8,353. Let's say 1,000 times to give me 7,000. Subtract it. I know 7 can go into 353. Let's say 50 times. Hopefully you just noticed what I did wrong, because as I said 50, I'm like, whoa, I did something wrong here. So what I need to do is I need to make this 1,353, because I have an extra 1,000 in there. So let's do, instead of 50, let's say 7 can go into 1,353 100 times. How's that? I'll change it to 100 to give me 700. You subtract, you get 3, 5, and then you cross that off. You get 653. Now you know 7 can go into 653. Say 90 times. Give me 630. 23 left over. I know 7 can, I need to shrink this. This is getting to be a long one. I know 7 can go into 23 3 times Give me 21, remainder of 2. You add all this together. 1193, remainder of 2. Okay. And the last method I'm going to do is my method 8,353. Let's call it the 7 method, where looks like you're drawing a 7 on the side. 7 can go in 8,353 1,000 times. Make 7,000. As long as I subtract properly, I'll get 1,353. It can go in 100 times. Give me 700. 3, 5, 6. Okay, it can go in 90 times. 630, remainder of 23. It can go in 3 times. 21, remainder of 2. Add all these together, 1,193 with a remainder of 2. Alright, so from this point on, I want you to go on and work on all these workbook pages that I feel like we're falling behind on, but not a big deal. Just a lot of practice work.